All right, welcome back. Hopefully this will be the last day that you'll be taking notes like this. I certainly miss being in the classroom and actually being able to teach. But I guess this will just have to do for all of us. We're moving on to lesson 5.2. At this point, you should have corrected 5.1 with your instructor. I guess it should be the same stuff, we'll see. We're going to start with a definition, which is something called an exterior angle. So we'll start by saying an exterior angle of a triangle is an angle that forms a linear pair with an angle of the triangle. Let's look at an example of this. Let's say, actually, hold on, I'll let you write this, I know I'm a little too fast there. Is an angle that forms a linear pair with an angle of the triangle. So let's say I have some triangle, and I extend two sides of it, and here's angle 1, angle 2, angle 3, and angle 4. Now if you'll notice, 1 and 2 form a linear pair. 1 and 3 form a linear pair. So we would say angle 2 and angle 3 are exterior angles because they form a linear pair. Similarly though, 4, is that exterior? It's outside of the triangle, but it's vertical to angle 1. So angle 4 is vertical to angle 1, so not exterior. Now you may say, well, why do you only pick that side? Well, not necessarily only have to pick that side. If I extended the other sides, I can do the same thing, which means that this is an exterior angle, this is an exterior angle. This is an exterior angle, this is an exterior angle. So the truth is, for every triangle, fact, at each vertex of a triangle, there exists two exterior angles. So that means in a triangle there would be a total of 6 exterior angles. And remember, at each vertex, those exterior angles have to be equal. This leads us to theorem 12. Actually, before we do that, let me give you a definition, another one real quick, of remote interior angles. The remote interior angles of a triangle are the angles that do not form the linear pair with the exterior angle. And you say, well, wait a second, how do you know again what side it is? The point is that any of the angles can be remote depending on which exterior angle you're looking at. What we'll mostly be looking at is a situation like this, where here's an exterior angle to angle 2, excuse me, to the triangle, and 3 and 4, they do not form the linear pair with angle 1. So we would say angle 3 and angle 4 are remote interior angles. Now, depending on what we're looking at, let's say this was angle 5, 6, 7, and 8. What would be the remote exterior angles of this? Well, 5 and 6 form a linear pair, 5's exterior. So in this situation, angle 7 and angle 8 are remote interior angles. They don't form the linear pair with the exterior angle, so they're remote interior angles. Okay, so that brings us to a really important theorem about exterior angles. Again, remember, exterior angles form a linear pair. The remote interior do not form a linear pair. And you can use kind of logic here before we even start the theorem. Let's say that we've got, if 1 and 2 form a linear pair, then we know 1 and 2 are supplementary by theorem 5. And that means they add up to 180. We also know 2, 3, and 4 have to add up to 180. But if 1 and 2 add up to 180, and 2, 3, and 4 add up to 180, then 1 and 2 equal 2, 3, and 4, which means that 1 equals 3 and 4. Now, the book proof is a little different, but since they've already given us triangle angle sum theorem, I'm using it. And this is going to be theorem 12, a very important theorem for us. You know what? I say that almost every theorem. All of the theorems are important for us. There are a couple that are not as important, but most of them are. All of them are. We're close enough. This is called the exterior angles theorem. And what it says is, the exterior angle of a triangle is greater than either remote interior angle. The exterior angle of a triangle is greater than either remote interior angle. And let's do the proof of this. So before we start, what are we actually saying? We're saying, let's draw a triangle here. And an exterior angle. Let's call this angle 1, this angle 2, this angle 3, and this angle 4. Once again, the book does this in a different way. I think our proof is valid because they did give us the triangle sum theorem earlier. If you want to go back and look at the book proof just for fun, or maybe on this long extended weekend you want to do an extra type of proof on your at your math party, feel free. We're going to say that given here is that angle 1 is exterior angle of the triangle. And I'm going to want to prove that angle 1 is greater than angle 3 and angle 1 is greater than angle 4. Make sure you get that. All right, so how do we start? Well, as usual with our fun proofs, we have a statement and a reason. And we're going to extend that and extend that. And we'll start with 1. Angle 1 is exterior angle of the triangle, and that is given. Step 2, if it's exterior, we know that angle 1 and angle 2 form a linear pair. Why? Definition of exterior angle. Good. And I'd like to be thinking when I'm at home and you are watching these videos that you are actually answering the questions. If they form a linear pair, then we know what about them? That they are supplementary. So we're going to say that angle 1 and angle 2 are supplementary by definition of linear pair. Okay, now wait a second. Definition of linear pair just says they're adjacent and uncommon sides form opposite rays. Exactly. Theorem 5 says they're supplementary. If they're supplementary, then they must add up to 180 degrees. Here we have my definition of supplementary, which says two angles, don't forget, two angles that have a sum of 180. We also know that angle 2 plus angle 3 plus angle 4 equals 180 by our good old buddy triangle angle sum theorem. Now see, when I explained how to do the proof kind of earlier, I said it in a very simple way. But that's how I worked out in my head what I was going to do. But now that I've got 1 and 2 equal 180, and 2, 3, and 4 equal 180, then I can say angle 1 plus angle 2 equals angle 2 plus angle 3 plus angle 4. By substitution, I'm replacing with something else. And if that's true, I can cancel the 2. By subtraction. Now wait a second. This isn't what I wanted to prove. What I wanted to prove was that 1 was greater than 3 and 1 was greater than 4. All I've shown is 1 is equal to those. But wait a second. 3 and 4 are both angles, they have to be bigger than 0. And they add up to 1, which is the whole unit. So we have something now from yesterday that says that angle 1 has to be greater than angle 3, and angle 1 has to be greater than angle 4 by what? Exactly. The whole greater than parts theorem. And then we do our QED, saying, you know what? I am done with this proof. Quo erat demonstratum. I hope I pronounced that correctly on video. In any case, go back to the beginning. What did we start with? It's an exterior angle, so it forms a linear pair. If it forms a linear pair, then it's supplementary. If it's supplementary, then it equals 180. If they equal 180. However, 2, 3, and 4 also equal 180 by triangle angle sum. I do my substitution, my subtraction, and then use my new theorem, and I'm done. Don't forget, I could have actually, if I had wanted, moved this step up any other place, since it doesn't rely on any of this information. But these 3 steps do have to be in order. Okay, again, very easy today. Very short notes. Don't worry, I know some of you are a little concerned that when I get back, the notes are going to stay short like this. You don't have to worry, we'll be having nice long notes the very first day I get back. I will be looking forward to it. So, with that being said, your assignment for this 3-day holiday weekend is page 192, 1, 9 to 13, 32 to 38. At 38, I want you to stop and then go to 39 and do to 45. I also want you to do, I believe there are 2 proofs on page 189, 47, and 48. You have a 3-day weekend to get this done, and then I'll be back on that Monday, hopefully as long as everything goes as planned. Thank you guys for your patience for these last 2 weeks. It hasn't been fun for me either. And I look forward to seeing you again very, very soon.